Hey folks, this is Shub from Mentor for You. So this is our first video on A-level mathematics, and we will be picking today with the quadratic equation. So this topic was also there in your GCSE curriculum. Well, in that it was like we just learned about some basic stuff like finding the roots and like forming a quadratic equation. But in today's, like in the A-level mathematics, we have a lot of things that we will be discussing in quadratic equation. So before going into the chapter, let me just give you a like brief introduction, what we will be learning in this chapter and what is the objective of that. So first, whatever we have learned in the GCSE mathematics, we will be learning that too, like finding the roots of the quadratic equation, that is basically solving a quadratic equation. So for that we have different methods that we will see in this chapter. So obviously the first one is the factorization, right? So which we basically know, like we all know about that. Then we have a formula that which we can use to find the roots of a quadratic equation, that's the quadratic formula. Apart from that, there is one more way how we can solve a quadratic equation, that is by squaring, by making a perfect square, that is also known as the vertex form of the quadratic equation, right? So we will also be learning about that, how squaring, making a perfect square of the quadratic equation, we can easily find the roots of the quadratic equation, right? Squaring equation, that is basically squaring the equation. After that, we will look how a quadratic equation is also treated as a function. Function in the sense that we'll have a function of y, and the function will be in terms of x. So when we plot the value, when we take different values of x as 1, 2, 3, so for those corresponding values of x, we will have some values in y. So we can draw the graph of any quadratic equation, and we can we'll learn how a quadratic equation is also considered as a function. So based on that, we will learn how to graph it. There are different possible graph of a quadratic equation. They are parabolic, upward parabolic curve, downward parabolic curve. We'll learn about that. Then at the end, we will be learning about the discriminant of a quadratic equation and how discriminant helps in sketching the quadratic equation. All right. So then let's start with the topic. So the first thing that we will be learning in the today's class and in the first video is basically solving the quadratic equation. So as I just told you about the different ways, so we have around three ways on how we can find the roots of the quadratic equation, or I can say that solve a quadratic equation. The first one is by the factorization. So I think we already have a pretty basic knowledge of how we can solve a quadratic equation by different ways. We have already learned that in our GCSE mathematics. Let me just quickly revise that part for you, right? So here we have again the quadratic equation formula. So I think most of you remember that formula. It was, for example, if we have a quadratic equation as ax square plus bx plus c, that is equal to 0. So to find the roots of this quadratic equation, what we can do is we can directly use a formula which is minus b plus and minus root of b square minus 4ac upon 2a. Right. And well, even for the factorization, there is a particular method which we should follow, and that's much easier as if we normally go for the hit and trial and break the middle term or the coefficient of x with respect to a and c. So what we can do is, if we have a general quadratic equation as ax square plus bx plus c, and we need to find the roots of this quadratic equation, or we need to solve this quadratic equation by the factorization process. So always remember a very easy method. Always multiply that a with that c, where a is basically the coefficient of x square and c is the constant in the quadratic equation. For example, let's say that a multiplied by c is equal to x. So after multiplying a with c, we will get some value. So what we can do is we can find the roots, or we can say that we can find the prime factors of that x, right? So then you just go for finding the prime factors. So we will have some set of prime factors. So the motive here should be like making such possible pairs of those prime factors such that when you add them, right, when you add those prime factors, let's say x is equal to prime factor 1 multiplied by, sorry, we should not just say that it should be a prime fact, it should be a prime factor. We can say that we should get those factors. When we multiply them, it should be equal to x, and when we add them, sorry, when we multiply them, it should be equal to AC, and when we add them, F1 plus F2, that should be equal to B. So we'll take some examples like how to use this concept, and that's a like much more easier approach just to factorize any particular quadratic equation, right? Then let us take a small example and let us try to apply this concepts. Okay. So here we have some examples, and let us try to solve these quadratic equations using the factorization techniques. So as I just told you that whenever you have a particular quadratic equation, you multiply the coefficient of x square with the constant. So for example, let me just put the heading here by factorization. So as I just told you, we have a quadratic equation, we have to solve it, we have to find the roots. So what we have to do here is we have to multiply the coefficient of x square, which is 1, with 15, with minus 15. So let us take it as 15 only and try to find the factors or the prime factors of 15, let's say, which is 3 and 5, right? So it is already like we have already broke the 15 as prime factors, which is 3 and 5. Now the motive here should be that I make such possible pairs of those factors such that when I add them, it should be equal to minus 2, and when I multiply them, it should be equal to minus 15. So the only possible pair that we can have here is x square minus 5x plus 2x minus 15 is equal to 0. Sorry, it's not 2x, it should be 3x. Right, now here we can take the things common, take the terms common. Here we have x multiplied by x minus 5, and here with this 3x minus 15 we have 3 common, so we can again take that x minus 5 common, which is equal to 0. Now again we have two terms, so in that both the terms, if I take that x minus 5 common, we will be left with x minus 5 multiplied with x plus 3 equal to 0, right? So that's very easy and convenient way to break the coefficient of x in the required terms, right? Similarly, let us try the same concept for the next question. Let's take the same, try to find the factors, or let us try to solve this quadratic equation. So first we should make it 0. So always remember that whenever we solve a quadratic equation, we always compare a quadratic equation with 0. The reason behind it, we will more discuss about those things in the quadratic as a function, right? So here we should do the same thing. Let us multiply that coefficient of x square with which is 6 with minus 5. Let's take it as 30 and try to find the prime factors here, which is 2 15, and 3 and 5. So out of those prime factors, we should make such possible pairs such that when we multiply them, it should be equal to minus 30, and when we should add those possible pairs, that should be equal to 13. So the only way it is possible is if I break 30 as 2 multiplied by 15. Right, so I can take it as 15 minus 2. Like I can break that 13x as 15 minus 2. So 15 minus 2 is 13, and 15 multiplied by minus 2 is minus 30. That's it. That should be the motive. So let's just break it now. So it will be 6x squared plus 15x minus 2x minus 5 equal to 0. Now we can take 3x common here. It will be 2x plus 5, and then we can take the minus common here, and we'll be left with 2x minus 5, that is equal to 0. That's it. Sorry, 2x plus 5, not minus 5. So now again we can take that 2x plus 5 common, which is left. So that will be 2x plus 5 multiplied with 3x minus 1, that is equal to 0. Right? That's it. So those are the roots of the quadratic equation. Like those are the factors of the quadratic equation. Now you just imagine that even I left that concept in the last part. Let me just conclude that statement here. So when you multiply two variables and the multiplication is equal to 0, what does that mean? That either one of the pair must be 0, like either 2x plus 5 must be 0 or 3x minus 1 must be 0, or we can say that both of them can be 0. So when we conclude or when we equate both of them to be 0, we will get some values of x. For example, here we have 2x plus 5, which is equal to 0. So x will be equal to minus 5 by 2. And similarly, 3x minus 1 is equal to 0, where x is equal to 1 by 3. So those are the value of x. When you substitute back in the quadratic equation, when you substitute those values of x in the quadratic equation, the complete value of quadratic equation will be equal to 0. So that's why they are also known as the roots. Fine, we will talk more about the roots when we go to the quadratic as a function. As of now, let us just try to solve the quadratic equation. Similarly here, in the last question, if we have to find the roots, what we will do, we'll just simply take one of them, like both of them to be 0 individually. X minus 5 is equal to 0 and x plus 3 is equal to 0. So the value will be like x will be equal to 5 and x is equal to minus 3. That's it. Similarly, you can take this question, try this, take it as a homework, write it down. I'll try to pin the solutions at the comment section. Don't forget to look once this is complete. Alright, let's move to the next part. Fine. Next, we have solving quadratic equation without factorizing the equations. Well, there will be some cases where we don't have to factorize it. Still, we will get the roots, or we can solve the value of x for which the quadratic equation value will be equal to 0. For example, this particular case, you can see that we have something on the left that's a perfect square, and that is equal to 25. The value of that equation is equal to 25. Now you can solve this equation by two ways. If you don't want to do it by the factorizing, if you don't want to do the factorization, even there is a method, but if you want to do the factorization, even there is a method for it. So let us try by how to find the roots or how to solve the quadratic equation without factorization for now. Then we will talk about that in a different video. So here now, if you see on the on the left, we have a perfect square there. So if I take a square root on both the sides, in that case, what will happen? It will be 2x minus 3 is equal to, like square is there, then I'm taking a root here, that is equal to 25 under root, right? So similarly, if you like, we have a square, then we have a root. So basically the power and the radicals will cancel out. So we'll be like just left with 2x minus 3. And root of 25 will be equal to just 5, right? But the problem here is whenever we have a square root, whenever we square a term, then we take a root, there will always be a plus and minus left behind it, because just imagine if that 2x minus 3 value is minus of 2x minus 3, in that case also we will get the same as the root, right? So we don't know that which value is inside that square root, right? That's why we take both the conditions. So for both the conditions, the whole equation will be true. So here we can say that 2x minus 3 is equal to plus and minus of 5. Similarly, if you like separate both of that, both the cases here, one you take it as plus 5, other you take it as minus 5, 2x minus 3 as minus 5. For both the cases, we'll get some value of x. So x will be equal to 8 by 2, which will be 4. And here x will be equal to, I think, minus 2. So that will be minus 1. Alright. So those are the values of x, or those are the solutions for the quadratic equation. So you can also try a different approach here. What you can do is you can open that complete square. You can open the brackets on the left hand side. First you square it, then you will have a quadratic equation. You compare that quadratic equation with 25, you make it 0. Then you go for factorization. You will get the same values. You will get the same values of the x as 4 and minus 1. All right. Similarly, in this part, on the next part, we have x minus 3 whole square as 16. So to solve for x, what we can do is we'll do the same thing. We'll take a root there. So x minus 3 whole square under root is equal to root of 16. So here we can see that whenever we have a square and then we take a root of it, so both of it, like both the values are possible. Or what you can say that, see, let me give you a proof of it. Let me just show you that. Root of 16, we can write it as 4 squared. Well, we can also write root of 16 as minus 4 squared, right? So that's what I was trying to say in the previous case. So whenever we have a root, so and inside that root we have a square, so we don't know what is inside that square. It can be plus, it can be a positive quantity, it can be a negative quantity as well. That's why whenever we square it, like whenever we root a square, we always put a plus and minus, right? So now if you want to simply take that square off, yeah, we can do it, no issue. X minus 3 whole square is going to be plus 4, or it, sorry, not square anymore, they will cancel out. So x minus 3 will be equal, can be equal to plus 4, or x minus 3 can be equal to minus 4. So x will be equal to 7 and x will be equal to minus 4 plus 3, which will be minus 1. So those are the possible values of x, or those are the solutions for which quadratic equation will be equal to 0, or the roots we can say, right? Similarly for the next one, well, in the last two examples we just had some real numbers as a solution, not exactly real, that's a whole number or a natural numbers. So there can be possibility that my roots can be irrational as well. So for example, in this case, if I try to take the under root there, it will be 3x minus 1 whole square under root is equal to, I can say it as root of 11 squared under root. Well, that is also true. So here, while solving this equation, it can be root of 11 squared, or we can also take it as minus 11 whole squared, minus root 11 whole squared. Even that is true, isn't that? So now while comparing the left hand side to the right hand side, we can clearly see that 3x minus 1 will be equal to root of 11, or 3x minus 1 is equal to negative root of 11. So 3x or x can be equal to 1 plus root 11 upon 3, or x can be equal to 1 minus root 11 upon 3. So both are again the solutions of the quadratic equation, we can say, right? Fine. So let me know if you got any doubt in this concept. I'll be responding to all of your comments, right? Feel free to ask me any of your doubts. You can also mail in the website in our email ID, which is provided here, right? I'll be responding you to whatever queries you have, right? All right. Then we have one. So next we have a pseudo quadratic equation. So the name defines the topic itself. It's a pseudo in the sense that it is not a quadratic equation, but it is a quadratic equation, because that's what an easier approach look like here. So here we have to solve the value of x for which this equation will be true. So the best way what we can do to solve for x is by taking squares both the sides. So if we do so, here we will be having 5x plus 3 whole squared is equal to, we have a root 3x plus 7, then we take a whole square there. So it will be 5x plus 3 whole squared will be equal to 25x square plus 9 plus 3 multiplied by 5x multiplied by 2, which is 15 to 30x. That is equal to root of 3x plus 6 whole squared. So that will be just 3x plus 7. Alright. So now we just try to take all the right terms to the left hand side. So that will be 27x plus 2 equal to 0. Now, as I just told you how to use the factorization technique to find the solutions of x. First, you multiply the coefficient of x squared with the constant, which is 25 multiplied by 2, that's 50. Then you find the possible prime factors, like find the prime factors, which is 225 and 2, sorry, not 2, that will be 5 multiplied with 5. So now we have to make such possible pairs so that when we add it, that is equal to 27, and when we multiplied it, that is equal to 50. So such possible pair is 25 and 2. So we break that 27x as 25x plus 2x plus 2 is equal to 0. Then we take 25x common, that is x plus 1. And here we have 2 common, we take it, that is again x plus 1. So now we can take that x plus 1 common from both the pairs. That will be 25x plus 2, which is left. Now to find the possible values of x, what we do, we take this x plus 1 as 0, so x is equal to minus 1. Again we take that 25x plus 2 is equal to 0 and x is equal to minus 2 upon 25. So these are the two values of x for which this equation is true. So that's all about the first class of the quadratic equation. In the next class, we will try to discover something more about quadratic equation. And so this is a plan to complete all the A-level lectures that will be completely provided free on the YouTube channel. You can follow to our other social media handles for good quality, good content on mathematics. It will be helpful for your step preparation, also for your A-level and GCSE exams. All right then, stay tuned. We will be uploading more videos on this content. All right then, fine. Thank you. We'll meet for sure. Bye-bye.